session. All set. Great. So welcome everyone to this session about mastering system design of web crawler. This is Ankit, and he would be sharing about the system design. So we'll be doing a mock interview in this. Welcome everyone to this session about mastering system design of web crawler. Awesome. So just was testing whether this streaming is working. So we see the streaming is working well. So welcome to all participants. And we have this session in the format of a mock interview where Ankit will be the interviewee and I would be asking questions to Ankit, and this format will help us share all the details about this system design of web crawler. And by looking into this interview, you will also get idea about how to answer system design questions. And this is a very important system design question. If you are preparing for Google, then this is a must-have question you should prepare. And this question is another, it's also important for the reason that it covers lot of concepts. It could be a high level design interview question, and at the same time it could also be a low level design interview question, because an interviewer may want you to dive into some of the algorithms, and it covers concepts of data structures. We will use queue, we will use hashing, priority queues. So a lot of concepts are used here, and at the same time a lot of internet and networking concepts are also used in this. So let's begin, and just give me a minute. We will adjust our screens so that this looks okay. Awesome. So now we are all set. We are about to start. So let's assume we are in an interview. So good morning, Ankit. This is
Good morning.
yes, this is your system design round. You have exactly 45 minutes, and I've gone through your resume. I have gone through your profile. My next question is design a highly scalable web crawler.
Sure. So let me share my screen so that I can start from the beginning and what are the requirements and what are the functional and non-functional things we require. So let me share the screen first.
Sure.
So do let me know once my screen is visible.
Okay.
Okay. My screen is visible?
Yeah, your screen is visible. You can yes,
Is my
perfect.
draw diagram visible?
Perfect. Yes, your diagramming tool is visible. So here, so as I have asked, as you have seen, I have asked a very open-ended question. I have asked that, okay, design a web crawler, and for a junior engineer, if I am the interviewer, so as you all know, I am Tarun. I have conducted hundreds of system design interviews for various companies like Microsoft, Oracle. So if I would be interviewing a junior candidate, then I may describe what is a web crawler. But if I am interviewing a senior candidate like Ankit, then no mercy. I'll just throw the open-ended question, just one line, and I want the interviewee to drive the discussion, because not only I'm evaluating his technical skills, I'm also evaluating his communication skills, leadership and initiative qualities. So yeah, continue, Ankit. So now you have the screen, and you can walk us through the design of web crawler.
Sure. So give me like 30 seconds. Let me draw some boxes so that I can easily explain them.
Great. But yeah, I would like you to first design or share what is the functional requirements you understand from web crawler.
Yes, sure. So yeah, just a second. Yeah, I'm almost done. So first of all, let me explain what a web crawler is. So web crawler is something like we need a system that can crawl the pages. So let's take an example, like I was saying, crawl the pages. Suppose there is a NoSQL database or a database user in which n number of documents are there. Let's take an example of Medium document. Like Tarun, I have seen many of your documents are published on Medium and they are very good articles. But like any let's take example of any of the Medium article, all the Medium articles have the content, and apart from that, they have a reference section. So, where- so if I take an example of suppose this is a Medium document, okay, this is a simple Medium document. When I Google what is the system design, I will get a Medium document. But in this, there will be n number of links which are attached to it. So the links, let's make it this. So there was a simple document, but each document was having two links. So take an assumption, suppose there is 1 billion of pages and average page size is 100 KB. There will be 100 TB of storage. 100 TB of storage will have n number of links. So what this web crawler will do, web crawler is such a type of system that can crawl web pages at scale, fetch the contents and store it for indexing and analytics. When I say store it for indexing and analytics, I mean we all are aware what LLM is as of now. LLM needs a proper context. So if suppose if like once this document, Medium document I was taking example, is having n number of references sections. What web crawler will do, web crawler will store them in a queue. Queue will have a different priority. We will be coming into this in like next few minutes. I'm just giving a high overview. What happens at the back end, what is the simple architecture. So queue will be having a different priorities, and upon that priorities, these things will be there. There can be a situation also in which the same link get repeated multiple times and it can be a deadlock situation. So this was a high overview. When I say there can be a deadlock situation, here comes the most important functional requirement of a web product, that is avoid duplication. So we know what is the like high overview what web crawler does. So if I wanted to explain in single term, single line, I can say it's a system that can crawl pages at scale, fetch the contents, and store it for indexing and analytics. The most
Great.
important things which comes in system design is, yeah, Tanu, you were saying something?
No, I was saying, yeah, very well defined what is web crawler. So just I'm summarizing. So a web crawler is a program who which can parse millions and billions of documents, and it is used for web searches, or it can be used for data mining. And in web searches, it can go through all the content, it can go through various link and do page ranking. And as Ankit brightly pointed, all the documents might have many duplicates, and whenever there is a change in document or the content, the web crawler should scan. So it's a dynamic program which goes through lots of content, and it should point out when something has changed, and it should be able to extract information for analytics or for various purposes, which includes AI or for search engines. So this is great definition. And with respect to functional requirement, first requirement is here that you have to parse the content, web pages. Go ahead and then share further functional requirements.
So what I analyze in running any of the system design patterns is there. We all know there is some functional and non-functional requirements, but we need to know in which order we should design our system. So I'm just writing some letters here. Just I will explain what this is.
Sure.
So if you can see, I have written RCAHD. Like this is a simple letter towards acronyms what I have analyzed in my mind so that I don't forget in interviews or I memorize it with my own terms. What like this means we need to follow the same sequence RCA HD. We are all aware what RCA is, what HD is, but that is a different thing. I've just taken the words from there to make it memorizing to use it some different ones. So what our style here is requirements. The first thing is we should be clear of the requirements of our system or what is our ask. The second is core APIs or core entities. Core entities are the main thing which will be required. Suppose in web programmer, what are the core entities? What is the minimum thing required in a web programmer to make the system functional? The next is APIs. What APIs will be used? The fourth is H stands for HLD. What will be the high level diagram for this? And the fifth stands for deep dive. Once we summarize all these four, what is the things which is missing and what is the thing we can add to improve our system? So these five terms can be taken in mind or always taken in consideration once you are designing a web program or any of the system design problem. So coming to requirements, requirements can be of two types.
Go ahead.
So here requirements can be of, let me make the diagram clear. So requirements can be of two types, which is functional and non-functional. Just a second. So coming to functional requirement, what will be our first functional requirement is we should be able to crawl the web pages. We should be able to extract the links from the web pages. We should be able to avoid the duplication. And there are like whenever we open a website, there is a what I can say function which is written or a like necessity or there is something which is compulsory is robots.txt which says I am not a robot. It should respect that I am not a robot also and store the fetch contains in it. Suppose if I'm studying about let's say example of AWS, if I'm like reading any document, I should be able to memorize it. So in similar way, web crawler should be able to store the fetch contents, what it has been fetching from that particular document.
So what is the
These are
input your web crawler will take?
what?
What is the input it will take? So I would say that, okay, design a web crawler which can take initial input, a list of seed URLs. So I may give you say thousands of URLs, and now your functional requirement should be to fetch all the URLs. You have to pass the content of all the URLs, and you have to also ensure that you do not store these content in any database with duplication. So you have to extract the information, assume that there are a lot of duplicate documents in this URL. So what you have to do is you have to extract the information, deduplicate the content, and store it efficiently in a database. So this is the entire simplified functional requirement.
Correct. The seed URL is the first one.
Yes.
I forgot everything. Correct.
Right.
And avoid duplication and everything, which are the necessity for us.
Correct.
Coming to the next thing, which is non-functional.
Non-functional, yeah. We can now
should be
look into non-functional. But yes, you also mentioned about robots.txt. So if you can explain about what is this file and what is the purpose, so that would be useful.
Sure. Just a second. I think my screen is lagging or just something a minute.
Okay.
Screen was.
So yeah, this could be another fourth requirement, functional requirement, that the web crawler should obey robots.txt. So by the time Ankit is sharing the content again.
Is my screen visible?
Yes, it is visible.
So yeah.
Perfect.
So we were talking about respect robots.txt.
Robots.txt. Yeah.
So, so basically robots.txt is a file based on like website like example.com, like that tells crawlers which pages they can crawl basically, which pages they should avoid, and crawl delay rules and site map locations basically. So meaning all crawls should avoid admin/admin permissions or admin necessity if that is in the page, and crawling/blog is allowed. Suppose if there is a blog, it should crawl that.
Great. Awesome. So just I'm rephrasing. So robots.txt file is a file which is created by the web admin. It is placed for helping web crawler understand the structure of the website. So it's basically in txt format the site map, and it shares what all pages web crawler is allowed to parse, and it will also uh, not list out pages which is private pages or pages containing confidential information. So your web crawler should not go into pages which are not allowed by the web admin, because this may result in blocking of the
IP and
web crawler.
yeah,
Right.
correct.
Perfect.
Some sites also block the IP, and especially Google and Bing respects it a lot. Is
Yes.
what like, and what I have observed is respecting these robots.txt is considered an ethical crawling behavior,
Absolutely.
so that we meet the requirement in everything.
Great. Awesome. Now
So
we can
coming
look
to
into non-functional requirement.
So coming to non-functional requirement, what I would say, first of all, my crawling should be efficient. It should be highly scalable, and I should get a result within seconds or within a stipulated time. It should not be any delay or anything. The Also the thing what we discussed, it should follow ethical crawling, that is polite crawling should be there. It should not break any rules while crawling any of the websites.
Right. So yeah, see this requirement. First requirement was, as I stated in the question itself, that should be able to deal with large amount of data. So it should be able to deal with petabytes of information. It should be able to read millions and millions of documents. So assume we are designing a web crawler for Google search. So there are 5 billion websites. So it should be able to go through all the documents, 5 billion websites or web pages. So yeah, you can say that, okay, it can go through 5 billion web pages. So that could be the scalability requirement or data volume with requirement. Second is low latency. It should be able to identify all the changes in all these 5 billion documents, and should be able to update the content within 1 day, right? So latency should be low. It is preferable as fast as possible, but yes, in no way it should be more than 1 day delay with respect to if some content has been updated. It should be able to update the content in the database in less than 1 day. I think now Google does this in few minutes, correct?
Yeah, correct.
So they
Because
update it
Google
very
is
fast.
Yeah, correct. So that's the thing. We should be focusing on the capacity estimation also. Like we can take an
Yes.
example of 1 billion pages, and
Correct.
each page size should be 100 KB. So there will be 100 TB of storage.
But I will
So-
share some more non-functional requirements as well. So one is data volume, large data volume. Second is low latency. Third is I would say that it should be yeah, so politeness you have already covered. So
Politeness,
politeness, that it should obey the rules of web crawler, web admins by following instructions as per robots.txt. It should not bring down the site. So it should also ensure that the same domain is not hit multiple times. So for example, if there is a web page which has hundreds of documents and I am hitting it very frequently, then I may slow down that particular website. So ensure that there is no performance impact on the documents which it is scanning. So these are the functional requirements.
Yeah, it should not hamper the availability of a particular domain or website updating.
And yeah, the other aspect is it should not have any duplicate contents, and it should not also repeatedly scan the same site. So it should do it in a most optimal way.
And
Great.
so I think we have done all the requirements part,
Yes.
which is functional and non-functional.
Yes.
So the next thing is coming to core entities. Take this block there. Let me create a new block for
you were talking about cost estimation or capacity planning.
capacity estimation.
Yes.
You explained in the terms of petabytes. Absolutely.
Yes. So no, let's do that simple calculation also. To
Sure.
first understand, so I have anyway shared the, say there are 5 billion documents, correct? Let's assume each of the document is 100 KB, correct? And then let's
Yes.
say 60% of information is duplicate, right? So just see what is the size of the data which we need to store.
So you are saying 5 billion.
5 billion documents. Yeah. Let's say
And 100 KB of page.
yes, 100 KB each on average.
And 60% or 80% we can
Yes,
assume
we
like
can assume,
duplication.
yeah, 60% are duplicates.
Okay, so
So
we
what
can
would
convert
be
the
the
capacity
database
estimation.
size? Yeah, what should be the database
So
size?
if suppose 5 billion pages, 5 billion total pages are there and every page size is 100 KB. So unique data is 40%. Like I'm
Yes.
I'm doing
Yes.
a minus from 100
Correct.
to 60.
Correct.
So 5 billion into 100 KB will be somewhere about 500 billion KB, which is 500 TB.
Yes.
So 60%, like 60% is 300 TB
Yeah.
will be duplicate and 200 TB will be the unique data what we are using.
Perfect. Okay. So
Okay.
3 terabyte is your size of the data which you would be storing. And let's
Correct.
say that, okay, to fetch these sites, again, different sites will have different performance. Some pages you would be able to fetch faster, some you would be able to fetch slower. So assume you take around 100 milliseconds to fetch all the to a single content you can fetch in 100 milliseconds. So what would be the total time? So will it be able to fetch everything in 1 minute, or if not one day? If not, how many such threads or processes you would need? So we can also calculate that.
So if 100 millisecond, let's take example for a single content and we need to focus on that 200 TB. So it will be somewhere like single thread process will take approx in years, what I can calculate.
Correct. Right.
And if I use some like if I use Google, like let's take example of some web search engines like Google or anything, they have some like thousand of workers or 1 lakh of workers, then
Yes.
the time can be reduced. If
Correct.
I use suppose 1 lakh of workers, it can be like 1.3 hours or 1.2 hours on that.
Correct. Correct. So definitely,
Plus,
yeah. No, you were right.
Multi-thread processing will be there, not a single thread, because a single thread is there, it will take years for this.
Okay, perfect. Sure. So, yeah, so this is few things. And what kind of data storage will you use? So from the latency requirement, because this is also, okay, can you calculate also transactions per second for the database?
Yes.
And is it a read heavy database or write heavy database?
So if that is a read or write heavy database, so that depends. Like if it's a read heavy database, I would also be going for hybrid cannot condition in that point. So if I calculate the TPS on this point,
Yeah.
so for like let's take example of 10,000 workers, it will be 1 lakh transactions per second.
Okay.
Yeah, 10 requests per second if we take for 100 milliseconds.
Yeah.
Suppose 1 upon 100 will be 1 upon 0.1, so it will be 10.
Yeah. So you are using multiple threads, and each of these
Yeah.
threads will be extracting the information and it will be storing the information in the database. So more threads you have, the problem is more write operations you will have, right? Simultaneously concurrent operations you will have. So ensure that database is not the bottleneck, and given the size of the database, how what kind of database do you think you would use to store the documents?
So if
Should we
we can
use a
see the
relational
core,
database or non-relational database?
I would go for DynamoDB only because DynamoDB is based on this one.
Sure.
Or Apache Kafka, Redis, or like RabbitMQ. Redis will be best in this one.
Mm-hmm. Okay. So if
For
you can
URL
see,
frontier and queue, like
yeah, yeah. So here, since the documents are 5 billions and it is in terabytes of data, and there is no relationship, so you don't need no relationships or capability to query on relationship or join, etc. So this will be good to, means for this scenario it's good to use any NoSQL database, correct? So it could be a document database or it could be any NoSQL database which can store text. So we are using text, and for simplicity we are not storing images, because a web crawler would also store images as well. But for the time being, we can consider this as one of the requirement. Okay,
what
go
I
ahead
have
with,
also researched is Cassandra is the most common choices in this web browser. What most of the companies use. Apache
okay,
Cassandra.
okay. Yeah,
Yeah.
so now having done this analysis, I'm not going into the bandwidth. So we should do calculation with respect to CPU. So we did calculation like what would be the processing time. We did storage calculation. We should also do network bandwidth calculation. So here it's 300 terabytes of information, and in one day. So again, no, network bandwidth will not be that much issue here because we are dealing with the text document. So next step would be to go into the core components, apply cap theorem here, and identify what kind of system is it.
Yeah. So yeah. So coming to core entities, like what I can say, core entities for a web crawler should be the seed URL, what you mentioned in the beginning.
Yes.
URL frontier, which is the queue and scheduler, which is the heart of the web crawler. DNS resolver, proper like converts domain name into IP address, that should be properly handled. There should be a fetcher and downloader which should fetch the contents for the web browser. Robots.txt handler, because if we don't respect that robots.txt, our IP will be blocked. Parser should
Yes.
be there. Link extractor should be there, so that we should get a, like if link extractor is not there, we won't be able to find new URLs on the pages.
Yes. Yes.
So these would be the core entities. What I can think. Yeah, these would be the core entities for a particular web.
Correct. So yeah, as we see that this would be a highly distributed system. So you'll have thousands of threads. So first thing is your input is in a file. Let's say a file containing all the URLs. This is your input. It might have say thousands of URL, and then within each of the URL you will have documents which contains more URLs, right? So you have to go
Correct.
through each of these URLs. So once you are given a document of URLs, what would be your first step of processing? How will you process the URL? You will go from first, second, third, like that in order, or how will you divide this file so that you can process it and fetch it uh, in multiple threads.
So the last point I did not go.
So you have a URL file, right?
Correct.
File containing say 10,000 URLs. This is your seed URL. And you have to fetch, as you said, that we will have a content fetcher which will
Correct.
look into the URLs and fetch. And let's say you have thousands of threads of content fetcher. So how you will read this file, how you will assign this file to all the thousands of content fetcher so that it can start fetching the content in a way that is a coordinated way, and more workers are not looking into the same URL, and they are also handling that there is no rate limit, or you are not kind of bombarding a site with the request.
So, like, what will be the typical sequence? What I can say is a page downloaded. Suppose example.com and slash page is the URL. First of all, you should be able to receive the HTML content. Then the second step would be
Even
create a
before
report.
that, what you will do? How will you get the URL? So I will give you a hint that, okay, given the list of URLs, what you should do, you should create a priority queue.
The
So
prioritize URL will be
yeah,
what
so
is
you have to
URL.
sort
Yeah.
your URLs. So you have to sort your URLs, and you have to identify that which URLs you will visit first, which URLs you will visit later. So one algorithm is, if the priority is given in the seed URL list, that is fine. Other way is you have to separate the domains, right, and ensure you don't call the same domains together, because the file may contain say one domain example.com, and maybe from link 1 to link 1000 there is all pages, web pages of example.com. So you have to ensure that these are put into some queue, and there is a multi-level queue. One is the queue for priority. You may determine the priority based on maybe the rank, or there could be some logic which you may use. The other way is you have to separate out the same sites within the domain so that you do not hit the same domain. So there could be multiple strategies to do that. You may assign different domains to different workers, but yes, how would you ensure there is a coordination between all the workers, because these URLs will be spread across the entire globe, correct?
Correct.
So where all you will instantiate the workers, you will be initiating these workers in different geographic locations, correct? So you may have
Yeah.
an algorithm where based on location you may assign the thread pools which are nearest, correct?
Yes, and also I can use multiple other algorithms, but like I said, priority based running also should be there. Suppose, let's take an example, there are n number of documents of AWS, correct? But there are some spam documents also. So I can sort them with the spam score depth level. If I'm reading about, let's take an example, how
Yes,
does how, like which iPhone is great as of now. So
correct,
there are n number of documents. Few of them will have a high depth and few of them will have a low depth. So I will sort them with that. So that is a priority based scrolling also.
correct,
I can also use the most important one, which is breadth first search, which is most common. Like
correct,
visit pages level by level on that point.
correct. Because in this document, someone may maliciously give you a
Correct.
self linkage or looping document, so that you should ensure that your web crawler should not get stuck, correct? If it goes into infinite loop, then that's a problem. So you have to ensure, so the next stage is you have to ensure there is coordination between various worker threads. So the way to
Correct.
do is you would need a centralized database where you can have the statuses of all the URLs, whether they are getting fetched or whether they have already been visited. So you have to maintain kind of one uh, maybe a store which can be
Correct.
used for coordination.
And also we should use freshness based scheduling on that point. Like we should order, like we should crawl on the new sites first rather than old sites so that our web crawler, what is functioning, is updated with the latest information.
Correct, correct. Perfect. So now coming to, so you need a database for managing the jobs, which is content fetching, and you need a database for storing the content. Correct? Now, if I say only store text, then that is straightforward. You may use Redis or MongoDB or DynamoDB, whatever you prefer, but NoSQL will be preferred because relational database will be overkill because we don't have to maintain transactions, so we don't have to we don't need asset properties. The other important thing is here what metadata you would be storing, right? So even if you have some metadata like some tech cloud or maybe some ranking, some number, ranking number, or summary, etc., you may also store as a metadata. So you have to design a database to store the metadata. So the content size was in terabytes. Definitely with metadata it will increase. So this is about the data. Now next thing is, how will you ensure that deduplication happens? So assume now we have solved the problem of having multiple threads and having a database which will keep the status tracking of all the URLs which are being visited. Now we have to insert to this queue. So we need a mechanism of a queue. So can we use here something like Kafka?
Kafka can be used, like it works well for a highly distributed systems. Other thing we can use is hashing. URL hashing can be used
Yeah,
on this point.
because there could be error scenarios as well. So for example, you try to
Correct.
fetch one URL and at that particular time the URL is not available, and or you receive some error. So you have to ensure all the content is fetched reliably, and the retries could be done if you are not able to fetch some content. Correct? And
Correct.
the other aspect is, yeah, how would you ensure that when you are fetching the content, you are not fetching the duplicate content? Because as I said, there are 60% content is duplicate. So
So
if,
I can use, yeah, a content hashing I can use first of all on this point, because different URL can still contain the same content.
yes,
So content hashing will be useful for me. And the second thing I can use is canonical URL checking also can be done. Like
okay,
HTML's, yeah, can like canonical, like what I can say, Crawler restricts canonical URL. That's a feature of it also.
yeah,
Distributed deduplication should be used. Like some same URL always goes to a same nodes. So this prevents false node duplicates also on this.
okay, okay. So let's talk about deduplication. So what algorithm or what hashing technique will you use in deduplication?
Like for this deduplication, URL hashing can be used or Bloom filters can be used. What I can think of.
Okay, so
Yeah.
tell what is Bloom filters?
So what Bloom filters is, like, for let's take example, for billion of URLs, hash tables becomes huge,
Yes.
and this can be a major problem. So what at this point we can use Bloom filter. It is memory efficient, it is fast, and it is like it is a high probability to detect duplications,
Okay,
and its complexity is 4:1, so which is quite
okay,
meeting the as per our requirements.
sure. So yeah, here one problem I see, that if suppose there are two documents, they do not match exactly, but say 90% is same content, 10% is different. So would you store both of them in separate copies, or you will store no only the differences, or yeah, what whether what how you will optimize this scenario? Because when you have even one single letter different, you will receive a different hash.
So at this point, like it's the thing you mentioned is 90% they are accurate and 10% there is a difference. So they
Yes,
are near duplicates. So they are near duplicates, not
yes,
exact duplicates, but they are near duplicates.
correct, correct.
So on this point, what I can say, I will keep one of the canonical version from them and store delta difference only. Like suppose if one document is having, let's take example of S3. Is S3 they have explained some of the features and some features they are missing. But the 5% or 10% what they are having difference, I can create a canonical versions from them and only store the delta difference in both the documents. What is being different? 90% is same. The only thing we need to find for the 10. So I will use store delta difference only. So I will compare the delta comparisons, what is missing and what is the difference between them. I will use version systems or like search engines on these points.
Okay, so now
And
I gave you
also
this.
we can use similarity thresholds on this point. So yeah.
Right. So I gave you that initial document size is 100 KB. So how many chunks or segments would you split the document to find the duplicates? Correct. So one strategy could be you divide the document into multiple parts and check for duplicates in each of the parts. Right. So
Correct.
more parts you divide, more accurate you will be, or more efficient you will be to identifying the duplicates. Right.
Correct.
But then there will be a problem because more calculation you have to do, more processing will be required, and for each of these partitions you can do some hashing, right? MD5
Correct.
or SHA-1,
Yeah.
and then
Yeah.
you can use Bloom filters to identify that whether the hashes are already there or not. Correct. And this will
Correct.
ensure that you will find out what segments are common, and you don't store the segments which are repeated or duplicate. Correct.
Correct.
Perfect.
Because blue filters and like these, what I can say, they have one-liner definition, one-line advantage also.
Yes.
They allow fast duplicate detection, isn't it?
Yes.
Yeah.
Correct. Correct. So yeah, you can figure out very fast that something already exists or not. Right?
Correct.
Awesome. Great. So if you can summarize this entire design, that would be good. We
Sure.
have covered all the aspects of web crawler system design. So yes, now you
Sure.
can summarize it.
So I will be summarizing the final architecture.
Sure. Let me check in the meantime also about some queries if we have. Awesome. So nothing on the queries side.
So this will be the, what I can say, the crunch or the conclusion diagram or final architecture.
Sure.
It will be starting from the C developer, the environment frontier, fetch worker, what we discussed, how many workers will be used, parser will be used, duplication, deduplication, we had a long discussion like loop filters, hashing, and proper storage should be there, Cassandra, ScalaDB, or any of the database which is not a requirement. And the last step is new URL, what we were getting. This I can summarize it. This is the final architecture for our web tool.
Great. Awesome. Perfect. So you have a seed URL, and then you
Yeah.
have the URL frontier. URL frontier will be the component which
It's the
will
heart of this web browser.
correct. Yeah, it will be doing all the processing about
Correct.
finding out the URL tree, correct? And
Correct.
figuring out whether there is a, possibility of denial of service attack or possibility
Correct.
of looping or deadlock situation, which is because of cross linking, etc. And it will also ensure that no domains are getting bombarded with lots of requests,
Correct.
and it will take care of retries, etc. So here we discussed that we may use Kafka queue, we may have dead letter queue, we may have a central storage of the jobs, what URLs have been visited, what are the new URLs, and what are under processing. Then you have a fetching worker. Fetching worker will be extracting the content, it will be parsing the content. So we may use some regular expressions here to identify whether the content has some URLs or not, and then you extract the URL. So fetcher worker will have logic to parse the content. Then it can segment the content, partition the content into multiple segment. It should be able to extract the URLs, and then it should be able to give it to URL frontier, which may create a priority queue, and then the queues will be processed by multiple threads of fetcher worker. And then you have a parser will be doing the parsing of the content, and then deduplication and detection of duplication will be there, and you will store the content as well as data uh, as well as the metadata. Correct?
Metadata.
Perfect.
Correct.
Perfect. So this is all about uh, the steps involved and components involved. Awesome. So yeah, quick recap. So here, what is important is you should understand the flow end to end. For interviewer, it is less important whether you are arriving at the right solution or not. What is important is what is your approach. Are you able to identify all the challenges? So here challenges where was data volume, about the latency, about denial of service attack, latency due to DNS resolution. So how we can optimize. So you don't have to have 100% understanding of all these networking concepts, but you should be able to identify where are the challenges and where are the complexities, and then how you will deal with this, how you will design distributed system. So here fundamentals of distributed system is very much important, and this is not a highly available system. This is a no, this is a system which is designed for availability. You should be able to uh, consistency means is something which is you may have an eventual consistency here. So you have to apply the cap theorem. So here no, that's why we have NoSQL database. So we did cost calculation, and the NoSQL database was chosen considering the database number of transactions. So there is a justification for each and every design choice which we made. And then finally, once you have the design, very must to share step is you have to share to the interviewer and tell them that how this design will meet all the non-functional requirements. Correct. So once you are able to convince the interviewer, then your job is done, and the feedback of interviewer is based on whether you are able to convince the interviewer with the design choices. Perfect.
I think our audience would like to know the feedback of this interview.
So yeah, no, I already shared that. Okay, one part which was missing was you have to share the design approach, right? So approach is more important. some of the aspects are no, I was able to identify that okay, it was memorizing. So no, so here the objective is not to do a right design, but follow the approach of an architect. Other thing is we have to be more structured, and you have to drive most of the discussion, so that if there are some hints interviewer is giving, that has to be avoided. You should be able to completely drive the discussion, and you should be also able to convince the interviewer. So yeah, I will rate 3 star out of 5. Also, diagramming you have to practice more, because the visual communication is also important. So you should be able to drive things. So two feedback, which is area of improvement. Practice more diagramming, so that you can draw and talk together. Second thing is you have to improve on the speed. You were aware of a lot of concepts. So no, most of the things which I discussed, you were aware, but it was not coming in your mind during the interview and in a organized fashion. So yeah, so you were jumping topics, but yes, to improve on this, more practice is required. So more you practice, more you do design, more you participate in discussions, then you will improve on it, and automatically a structure will come, and you will be able to recall. And when you have speed, you will be cover the entire design in full breadth. So most of the interviewees, they fail because of less speed. Some of them know everything, but within 45 minutes they are not able to cover everything, and put some time at the end. So we did good with respect to time. So in first 5 minutes we did the introduction, then in next 10 minutes we did the functional requirement, and non-functional requirement was also done within 15 minutes, and then we did uh, cost or envelope, back of envelope calculation, and then finally we started using the high level design diagram for creating the diagrams. Perfect. So then we will share.
We will be doing over this weekend.
Awesome.
So yeah.
Great.
So I will be focusing on the feedback so that speed is better, because that itself is a very huge architecture.
Yes, yes, absolutely. So this was also a pretty hard topic. So this is something like which is asked in Google interviews very frequently, and if they are hiring in Bangalore, they have the Google search team. So they will generally, if you are doing very good in interview rounds, then they will consider you for Google search, and then they may ask you something similar system design question. And nowadays web crawlers are being used for hundreds of purposes, not just in search engines but in AI as well. So this makes this topic very important, and we will share, so I will share some notes also in the comments for your references, so that everything is consolidated and easy for you to revise. And then yes, we will be doing on Saturday system design of Uber. So let's see now how much improvement Ankit can do in the next interview. So you can think of like this was your first round of system design, and then there is a second round, and your goal is to get a strong higher rating. So now you have got like higher rating in this time, and now if you get strong higher rating, then this will be good, because you will get a promotion when you get hired, right?
Sure.
If you do the same way, then you may not get that desired role or desired hike. So it's always good to kind of aim for getting a strong higher rating. So good job.
Sure. Thank you, Tarun. So, like, we will be continuing this series for a long time. We have a number of partners, so I'm thinking we can continue this every weekend. So
Absolutely.
it can be helpful for audience also. So they can learn from my feedback, and also I will be also getting this as a improvement fund.
Yes. And for audience, no, I am also sharing my very structured course on system design. So I have shared some 5 episodes of sessions. I'm sharing them every few days so that you get time to go through them and you are not bombarded or overwhelmed with too much of content at the same time. So there I talk from all aspects starting from so I got a comment, Ankit, from the audience. They are saying you are a strong hire. Awesome, awesome. So this is thank you from VK DevOps. So yeah, I was saying that okay, I have covered system design very thoroughly. I've cleared myself Microsoft and Google interviews. So I have also interviewed so many candidates. So I understand what interviewer is looking for, and I have also worked with various engineers, hundreds of engineers all across the world. So I also understand their mindset, that what they look in when they hire someone. So yeah, I'll keep sharing, and with the help of Ankit, more content on system design. And Ankit is a certified professional, and you can connect to him over LinkedIn. We will share his profile details also, and he also regularly shares content on system design. So we will share all these details. Thank you. Great then. So
Sure. Thank you, Tarun. Happy weekend.
awesome. Then we can close the session if there are no questions. So I will wait for 1 minute for audience to post any questions. If there are any about web crawler or about the system design of web crawler. Anyway, we have recapped it. So audience seems to be good. Great. So fine, let's close this session and
Thank you,
let's
Tarun.
meet again with the next
Yeah,
round.
on Saturday.
Sure.
Yeah. Sure.
Awesome. Thank you. All the best.